Good evening everyone. Welcome to Tech Tutorials 2K21. Myself Devi Chokkakula. So today we'll see the introduction to the C programming language, the part 2, which consisting data types, different types of operators, expressions, operator precedence and associativity, type conversion and typecasting. So these are the topics we will discuss today. And I'll start with data types. So why data types is required for any programming languages? When you return some code in programming language, that may be of any programming language, we have to inform to the compiler what type of data you are going to use, and we request for the compiler to reserve some memory to hold temporarily our data. And that can be accomplished in programming languages by using the concept of data types. So in C programming language, data type will specify the compiler about two things. The first thing is what type of data that needs to be stored and what type of data we are going to handle in future with our programming, and how much memory is required to hold that data. In C programming language, there are three different types of data types are available. Those are primitive data types, derived data types, and user-defined data types. So the primitive data types, that is given by the programmer itself when they implemented the C programming language. So they provided some inbuilt data types. Those are said to be primitive or primary data types. They are character, integer, floating point, and void. So these are the primary or primitive data types in C programming language. Again, these primitive data types, they can use with a combination of signed, unsigned, long and short keywords. So which will give you the different view of the data in programming language. So here it is a primitive data type or a primary data type, which consists in the basic data types like integer, floating point, and character. And each and every data type is having some memory to hold that particular data, and depends on the data type we are specified, the compiler can reserve a memory for you. And here we can observe that the character data type is used with a combination of signed, unsigned, and float can be of float, double, and long double, and integer can be int, short int, long int, unsigned int, signed int, and you can use the combination of both also, like short signed integer, short unsigned integers, right? You can use that combinations and will make it the integer with a different size. And void is also a primitive data type but doesn't return any value. So simply we can say it's a null representation. And whereas the derived data types, which can be derived from an existing primitive data types, so we can derive pointers, arrays, structures, and unions in C programming language. For creating these new data types, we can use an existing data types, that is of your primitive data types. So we can create an array with an existing data type integer, float, and we can create a string which is of one of the derived data type by using a primitive data type character, and we can create a structure with a combination of these primitive data types as well as unions. Whereas the user-defined data types in C programming language, it allows us to create our own data types. So that is also possible. So the user-defined data types are derived by the user itself, And there are two types of user-defined data types available in C programming language. One is enum, that is an enumeration, and the second one is typedef, that is a type definition. So these are two user-defined data types existed in C programming language. So this is an overview of data types. So we'll see in brief about each and every data types in C programming language now. So now coming to primitive data types, and these are fundamental data types in C, which is named as integers, floating point, character and void. So we can use the keywords int for taking a data type integer, and we can use the float keyword for taking a data type floating point, char keyword for the character, and we have a void keyword. So when you observe this diagram, so these primitive data types are of four categorizes: character, integer, floating point and void. So we'll discuss about the range of each and every integer and the size of each and every data type a little bit later. In this diagram, we can find out that the character can be taken in three different representations like char, signed char and unsigned char. So I will give you a differences between signed character and unsigned character a little bit later. So we move on to the integers. So again it can be categorized with sign unsigned. So now you can take up these combinations like sign int, sign short int, sign long int. For unsigned integers, we can take unsigned int, unsigned short integer, unsigned long integer. So signed and unsigned representation is the signed integer values, it can take both positive and negative values. Whereas unsigned integers, it can take only the positive values. It cannot accept the negative values. For the floating point, and these data type is used to accept the decimal values. For accepting the decimal values, we have two different data types is available in primitive data type. One is float and double, and the ranges it can be varied from float to double. And if we want to represent a largest decimal value, we go with a long double combination. Whereas the last primitive data type is a void, which doesn't return any value. So now we'll discuss about each and every primitive data type along with their size and ranges. So this is the first one is an integer data type. So these integers are used to store the whole values. So integers can be used along with signed, unsigned, short and long combinations. So now see, this is a data type, and then how many bytes it can occupy and what will be the range. So for integer, again the size of the data type is depends on the type of the processor we are going to use. Suppose for example, we work with a 16-bit processor, 32-bit processor or 64-bit processor. Depends on the processor size, the data type sizes it can be varied. So we'll discuss these ranges or these sizes. So depends on a processor with size 32-bit. So when we discussed or when we worked with 32-bit processor, the integer can occupy 2 bytes of memory, and it is capability to take the ranges, the minimum and maximum. So I already said for signed integers, it is ready to accept both positive and negative values. And it will accept the ranges on negative side minus 32,768 to 32,767 on positive side. So I will show you how you are going to calculate these ranges. So for that, so here I said already for integer, so it occupies 2 bytes of memory. Suppose if you take keyword integer. Now it occupies 2 bytes. So 1 byte is equals to 8 bits, whereas 2 bytes means it will take 2 into 8, 16 bits. So whenever you want to find the range of integer, if it can hold both positive and negative values, because we are taken int or signed int, both are same actually. So it can take both positive and negative values, that is of an integer values. So how we are finding the range of an integer is, we can take 2 power 16. So it will give you the value as 2 power 16, that equals to 65,535. So the range is 65,535. So this will be the maximum integer value a 32-bit processor can hold. So whenever you assign integer or an integer can capability to take both positive and negative values. So now this 65,535 is divided by 2. So now it will take a scale like this. So this is 0 and this will represent positive value and this will represent the negative value. So when you divide this 65,535 by 2, and it will give you on negative hand side, that is 32,768, and on positive side it including 0, it can take maximum of 32,767. So right, so the maximum capacity of an integer is 65,535. So when it is of a signed integer, it can take both positive and negative, so that the entire range is divided into 2 parts. So on negative side it can represent the maximum of minus 32,768. On positive side it can include 32,767. So you can give the value in between these two ranges, then you can provide it the integer value properly for your variable. So for unsigned integer, the size of this integer is also 2 bytes and it can hold only the positive values. So there is no negative, only positive values it can hold. So because of that, it can take values from 0 to 65,535. So for short integer or signed short integer, both are same, and the size of the short integer is 1 byte. So that is only 8 bits. When you try to calculate the range, it is 2 power 8, that is 256. So because of this is a signed short integer or short integer, it can keep both positive and negative values. Because of that, again it will be divided into positive and negative side. So on positive side, it can accept maximum of 127. On negative side, it can accept maximum of minus 128. I hope you all understand how to calculate the size, how to calculate the range of a particular data type. So now for unsigned short integer, so when you said it is unsigned, it can capability to keep only the positive values, and the size of unsigned short integer is 1 byte. So So it can keep values from 0 to 255 because 2 power 8 is 256. When you start ranging from 0, it can keep the last value as 255. For long integer or signed long integer, the size is 4 bytes. So that is 2 power 32 because 1 byte is 8 bits. When you go with 4 bytes, that is 4 into 8, 32. So 2 power 32 will be the maximum range of an integer that compiler can hold. So for that, it will take the value of 4294967,296 and it will be divided as two parts. On negative side, it can keep minus 2, 147,483,648 will be the maximum integer value. On positive side, it can keep 2, 147,483,647 on positive side. So this is about an integers. So when you work with an integer, what will be the maximum range we are expecting for your program depends on that we can choose any one of these combinations. So in default, any programmer, they can use the integer data type as int. So that represents as a sign int. And if you want to change the range and we want to represent only the positive values, then we go with unsigned integers. So whenever we don't want to waste 2 bytes of memory, we have a values from 0 to 255 only, then we go with a short integer combination. So the next thing is floating point data type. So floating point data type is used to store a real numbers, that is our decimal values. And the size of floating point is 4 bytes for 32-bit processor. For double is 8 bytes. For long double is 10 bytes. So it depends on the range. We can use any one of these data types for storing decimal values. So this is the ranges of float. So by float, we can take like 2 power 32 because 4 bytes is nothing but 2 power 32. Whereas double it will be 2 power 64 because 8 into 8. For long double it will be 2 power 80 because 1 byte is 8 bits and for 10 bytes it will be 10 into 8, 80. So this will be the maximum range for 2 power 80. So it can represent for both positive and negative side. So it will be taken like this. For double it will be 1.7 exponential of minus 382. On positive side it will be of 1.7 exponential of plus 308. For floating point it will be 3.4 exponential of minus 38. On positive side it will be of 3.4 and exponential of plus 38. So this is about a floating point. And the next one is character. Whenever user want to operate with the characters, then they are going to use a data type as character. So by using this character data type, I can store the character values in my variables. So for this character data types, I can use two combinations like character simply or signed character, or it will be of unsigned character. And the size of character or unsigned character both will be 1 byte. So 1 byte means 8 bits. So in order to represent one character, it needs 8 bits for that character representation. So when you go with a signed character, it can capability to keep both positive and negative values. So 1 byte is nothing but 8 bits. So 2 power 8 is equals to 256. That will be the maximum character range. So when you go with a signed character, it can take both positive and negative. So on negative side, it can keep minus 128 will be the maximum value. On positive side, it including 0, it can take maximum of 127. Whereas unsigned character, it will take only the positive side so that it can take a maximum range, that is 255. And the last primitive data type is void. So void type means there is no value. So this is usually used to specify the type of function which returns nothing. So when you use your main function or some subfunctions in C programming language, we have to provide some return type. So you are not providing anything before your main function. By default, your C compiler will treat it as void, as a return type to that function. So it doesn't require anything, or it doesn't expect anything written back to your main function. Whereas you can specify any of other data types like integer, float or double, whatever it will be. It expected that type of value to return back to your main function or your subfunctions. So for that purpose, you are going to use this void data type, and these are the primitive data types we have in C programming language. And we'll move on to derived data types. So the derived data types are created from an existing data types. In C programming language, we have different derived data types like arrays, structures, unions, pointers, and all these things. So here at introduction part, I'll give you only the definition of an array and how you're going to declare like an array, structures and pointers in C programming language. I'll provide in brief about all these topics later because we have every topic as a separate topic to discuss in C programming language in brief. So the array is a derived data type which is defined as a collection of similar type of data items. It stores at contiguous memory locations. So we can use any of your primitive data types like character, integer, float or double to derive an array data type. And the next derived data type is structure. So it is reverse to your arrays. So array can hold similar data, whereas your structure or union can hold different type of data items. Simply we can say structure is a collection of heterogeneous data type. Like we can keep a different data types. Whereas a pointer, so this is also one of the derived data type in C programming language. So the pointers are a special type of variables in C programming language which can hold the address of another variable. So I will show you how you are going to derive data types in C programming language with a simple illustration. So I'll start with an array. So I already said array is nothing but it's a collection of similar data types. So when we are going to use this arrays concept in C programming languages, suppose if I have 10 integers, so simply I can use my declaration of an integer concept. I can keep the data like this: int variable 1 comma variable 2 comma variable 3 comma variable 4 and so on variable 10. So I have 10 variables in my program. I want to use these variables in my program in different areas or for the different purposes. So whenever in C programming or any programming language, when you operate with a multiple variables, it is difficulty to keep in mind. So for what purpose we are going to use a which variable or something like that. So this can be eliminated by using your arrays concept. So we can declare all these 10 variables in one place because all are of integers only. So I can keep it one place and I can derive an array like this. So for declaring an array or for deriving an array, I have a syntax like data type and I can specify my array name And these brackets are said to be, these are square brackets, and these brackets are said to be subscripts. And within the subscript, I need to specify the size. So here my aim is I want to create 10 variables. So I am provided my size is 10. So when you given this array, the compiler can understand. So now in your program, you are going to use you are going to use 10 integer variables and they are keeping with a single name. See, for example, for integer, I will take int and my array name is num, and I want to create this array with size some 10. So now my compiler can understand, okay, so I have 10 integer values and I'll keep in a single name which is said to be array. So when I want to refer these 10 variables, instead of referring like v1, v2, v3, v4 like that, so I can use a single name that is num. So this is an array. When come up with structure, so you can take any type of array. Suppose if you want a floating point, then you can define like float some average of some 5. You can take character, char, gender of some 10. So like this you can provide. You can take any data type which is available from your primitive data type. That's what we are discussed. So whereas the structures, so structures are used to create for a multiple data types. So simply in C programming language we have a keyword like struct. So here we have to provide your structure name. So this is the syntax, structure name, and here we have to provide your data members. So I can take a data members of different types. So I can group it as a single. So you can create any number of data members here. So you can take up to n and then you can close with semicolon. Suppose if I am created a structure student, so I can use simply my keyword struct and student is my structure name. So a student can have a different informations like student name which is of type character. So I simply provide like char name of char name of something. So I can take roll number which is of type an integer. So here I can keep, I'm trying to write my structure here. So I can hold a different data types. For my structure. So here I can take name, and I can take the roll number of student, so integer, and I can take fee of that student of type floating point. So I can keep fees of type floating point. So now I can group up so all these different data types under a single name student. Whereas the last one is a pointer variable, which is also one of the derived data type, because the pointer variables is also created with these data types only. So like I can create an integer pointer, simply I can use an asterisk symbol. So simply I can use an asterisk symbol like asterisk pointer 1 or pointer 2 like that. So in this way I can create a derived data types from the existing primitive data types. So whereas the third category is user defined data types. So user defined data types are used to create our own data types. So that is possible in C programming language by using two keywords like enum and typedef. So enum or enumeration is a user defined data type in C programming. It is mainly used to assign names to an integral constant. That names, it makes a program easy to read and maintain. So we can use a enum keyword like this. For creating a user defined data type. So this is a way how you are going to declare one enum data type. Like this is enum is a keyword here, and you can create an enum for a group of things. Like you can take month, it will consisting, or you can take year, it will consisting 12 months. You can take color, it is a group. We can group a different colors. So for that you are going to use this enum. So what your enum will do is it will assign some integer value for the variables or the enumerators what you are provided in a as a list in a flower braces. So here enum is a keyword and days of a week is a enum variable. So from that I am passing 7 different days like Sunday, Monday, Tuesday, Wednesday like that. So here I default it will assign the first enumerator with 0. If you want to change it, you can directly assign whatever the value you want to assign for that. Suppose for example, if I assign Sunday with 10, it continue Monday as 11, Tuesday as 12, Wednesday as 30 like that. Or else it is also allow for you, you can create your own different data values to this enumerators. Suppose if I am assigned Sunday with 10 and I am assigned Wednesday with 20, so how my enumerator is created as, so if I assign Sunday with 10, the Monday is treated as 11 and Tuesday is treated as 12. So again I explicitly created Wednesday with 20, then Thursday will taken as 21 and Friday will taken as 22 and Saturday will be taken as 23. So if I want to refer these enumerators, I need to create an object for my enumeration variable. So here we can observe that day is an object which I created for days of the week. So by this object or an instantiation variable, I can access I can do operations on my enumerators. So what this operation will say is, I want to assign the value of Wednesday to my object day. So if I'm providing like day equals to Wednesday, so what it will do, see. So here we can take for Wednesday, if you start your Sunday with 0, then it will be 1, Tuesday with 2 and Wednesday will be 3. So it will assign an integer value as 3. So this is a way how you are going to create enumeration in C programming languages. So whereas the second user defined data type, that is a Typedef. So Typedef is a keyword which is available in your C programming language, which is used to create the type definition of user defined data type. So this Typedef user defined data type, which allows you to creating an alias or duplicate name for an existing data types. Again, an existing, it will be of primitive or derived data types, because before the user defined we have existed with primitive and derived. So you can take any of primitive or derived data types and we can provide a duplicate name or an alias to that particular name. Suppose this is a way how you are going to define your user defined data type. So simply we can say Typedef, and this is your existing name, and alias name is nothing but for what name you are going to assign for this existing name. For example, see, Typedef is my keyword. I want to refer unsigned integer as unit, UNIT. So we can say it as unit. So instead of every time I'm going to write unsigned integer, simply I can use unit instead of unsigned int. So when I am using like this, the compiler can understand what are the variables I declared under this particular user defined data type. That will be the category of unsigned integers. So here I provided how you are going to use this unit. See here, I provided unit A comma B. So when compiler can identify this, it can understand A and B of a variables of type unsigned integers. So you can give any name to an existing data types, and later in your program, instead of an existing data type, you can give your alias name for representing the same. So that is the use of Typedef data type in C programming language. And the next topic is operators. So now operator is a symbol in any programming language and that are used to perform a specific operations in programming languages. So in order to perform any operation, like we want to perform any arithmetic, relational or something whatever, so we need to use these operators in C programming language. So in C programming, we have 8 different types of operators are available. So one is arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, conditional operators, increment or decrement operators, and the special operators. So these are 8 categories of operators available in C programming language. So we'll discuss about each and every operator in brief. So we'll start with an arithmetic operators. And arithmetic operators are used to perform mathematical operations, that is of basic mathematical operations such as addition, subtraction, multiplication, division and modulus. So this table illustrates how we are going to use these operators. So see, for example, if I want to use an operator plus, I need at least 2 operands. So what do you mean by an operand? Operand is nothing but a variables or the constants which we provided on both sides of your operator. Simply we can say in between operands we always place your operators. So we can use like plus operator x plus y, and later you can provide values for x and y with sum, so that it will add those two numbers. For subtract it will minus, for multiplication it will do the product, for division it will take a value from coefficient, whereas the modulus it will take the value from remainder. So I'll discuss with a simple example so that you can understand how the arithmetic operators can work. So I already said arithmetic operators are used to perform basic arithmetic operations like additions, subtraction, multiplication and division. So arithmetic operators So we'll move on to the next operator, that is a relational operators. So in C programming language, the relational operators are used to check the relations between any of two operands. So these relational operators are used in control structures. Basically, depends on the relation it will find between the operands, it will return a Boolean values. So the Boolean value is nothing but either it can return 0 or 1. So 1 indicates the value as true, whereas the 0 indicates the value as false. So we have a different relational operators available in C programming language, that is less than equal, greater, greater equal and not equal. So here you can go with some examples. X less than y. So it will check whether x is less than to y or not. And x is greater than y. It will check whether x is greater to y or not. And it will check x is less than or equals to or greater or equals to. And x equals to y. It will check both x and y are equal or not. And x not equals to y. It will check whether x and y not equal or not. So for example, if you are taking x is less than y, I will assign x value with 5 and y value with 3. So now it will replaces the x and y values there. It will give you like 5 is less than 3. So we all know 5 is not less than 3. So now this expression is going to return a value as false. Suppose if I check x equals to y, I will assign x with 5 and y is also with 5. So it will take x and y values as 5 and it will check 5 equals to 5. Yes, 5 and 5 both are equal. So in this case, it will return our answer as true. So that is, it will return a Boolean value as true. And the third type of operators are the logical operators. And these logical operators are commonly used in decision making itself in C programming language, which is used to perform some logical operations. So in C programming, we have three different types of operators are available in logical operators category. So that is logical OR, logical AND and logical NOT. So these operations can be implemented by a logical gates. So simple logical AND gate, OR gate and NOT gate. So these are the truth tables for AND, OR and NOT gates. So when you go with this AND gate, it will take two inputs and it produce one output. And that output will be the product of these two inputs, we can simply say. So what this truth table will say is, when you generate a truth table for AND gate, it will take two inputs A and B and it produces output as A and B. So what your AND gate will say is, if both conditions are true. See, here is a case, when I have two inputs, I have only two possibilities. I can provide both are false. One is false and true, true and false. And then I can provide both are true. So those are only the possibilities I can provide it with my two input AND gate. So now AND gate will provide these are the outputs. So when both inputs are true, then only the output is true. Otherwise it returns false. Suppose if I am taking two conditions, the first condition is 5 is greater than 3 and the second condition is 2 equals to 5. So my first condition will say 5 greater than 3. Yes, the condition is true because 5 is greater than to 3. Whereas the second condition will say 3 equals to 5. So 3 is not equals to 5, the condition failed. So the first condition true and the second condition false. Now it will return the output as false. So whenever in C programming language you want to make a decision logically, depends on your requirement, we can use any of these three operators. So the next operator is logical OR, which simply we can take at output side like C equals to A plus B, and here also you can observe that this will take two inputs A, B, and this is a truth table. So your OR gate will say if any one of the input is true. See, here is a possible 0, 1, 1, 0, 1, 1. Any one of the input is true, then your output is true. So now you can use this logical OR where we can take a decision, right? When we have a multiple conditions. If any one condition is met true, then you can make a decision as true. Then we go with this logical OR in conditional part for making a decision. Whereas NOT gate, it will take only a single input. So it will act as a complement, like if you provided true as your input and it will check whether it is false or not. Means it will return false. If it is checked false and it returns true. So in this way this logical NOT gate is going to work. So it depends on our requirements. In C programming language, we can use these logical operators in program. So the next operators are bitwise operators. So the bitwise operators are used to perform the operations at bit level. So while separated like logical operators can do an operations on data, whereas the bitwise operators can do operations at bit level. I already said when you take any of type data, like it may be of an integer, float, character or double, whatever it will be, and the sizes they will specify like 1 byte, 2 bytes, 3 bytes, 4 bytes, 8 bytes like that. So when byte is nothing but 8 bits, when you go with a logical operator, it combinedly worked on a complete bytes. It cannot separately take a bit by bit and it cannot do any operations on that. Whereas the bitwise operators, we can do the operations at bit level. For example, here we can say bitwise end of 6 and 3. So we are taken here 6 and 3. So now the 6 is represented in binary as 0, 110. That is a representation of 6. Right? We can say simply that is 0, 110. Whereas 3 can represent it as 0, 011. Right? 6 is represented as 0110, whereas 3 is represented as 0011. Okay. So now you are doing AND operation. What your AND operation will say? So it always says like if both are 1, then only you get your output is 1. And you are finding in 0110 and 0011, you are finding at the second position element both are ones. So now the output is 0010. So now the result equivalence to its decimal is 2. So because of that, the bitwise AND operator is going to return the result as 2. So the same way we can apply bitwise OR, bitwise exclusive OR, and bitwise ones complement. Right? So bitwise one complement is also like suppose see for example if you want to take a value 9 in decimal, that is keep a value in binary, so it will take the value as using 8421 code, it will take value as 1001. 8421 code, we can enable the bits where we require. Suppose see for example, if I operated with my bitwise operators, so it can operate at bit levels. So the next operators are assignment operators. So these assignment operators are used to perform basic assignment operation. So, and these operators are also used for shortcut notations in C programming language. So, the assignment operators are is equals to, plus equals to, minus equals to, multiply equals to, divide and modulus equals to. So, always the assignment operators are used to assign some values which is provided on right hand side to the left hand side of variable. Suppose if I am using like a equals to 10. So now the value 10 is assigned to a variable a. So these assignment operators I can use for shortcut notations. That is, if I want to use x equals to x plus y, instead of I mention x 2 times, so simply I can provide x plus is equals to y. So that implies that it equals to x plus y. So when you are going to use a shortcut notation is, on left and right hand side, we have the same variables, then we can use these shortcut notations. And the next operators are increment or decrement operators. So in C programming language, this increment and decrement operators are used to performing addition and subtraction operations on variables. And these increment and decrement operators are used for the processor itself for incrementing and decrementing the program counter values. So here I am going to explain with the variables. So when you use an increment operator, it will add 1 to a variable. When we use a decrement operator, and it will subtract 1 from the variable. So the increment and decrement operators are categorized again into two ways. One is prefix and second one is postfix. So prefix is nothing but we can provide this increment operator before the variable like this. See here we can observe that plus plus operator is provided before x. So such type of things is said to be prefix. The same applied for decrement operator also. So here instead of plus plus we are going to use minus minus there. So for postfix increment operation, we can provide this operator after the variable. So simply we can say x plus plus. So we are succeeding with this variable. So for postfix decrement also we can provide minus minus operator after the variable. So what the differences between the prefix and postfix is? So when you use a prefix increment operation, so first it will increment the variable, then it will use that value. If you use a post increment, first it will use the value of x, then it is going to be incremented. Suppose if I am given my x value is 10, I said plus plus x, instead of using 10, it will use 11 because the variable will get incremented first and then it is going to be used. Whereas in my postfix increment, if I take say my x value is 10, I am doing x plus plus. So it will take x value as 10 only. Because as a post increment it will say return the value of x first, then increment. So this will be the difference between prefix and postfix. We can apply the same thing for the decrement operation also. Whereas in decrement, we can perform the subtraction operation instead of addition. And the next operators is conditional operator, which is said to be a ternary operator in C programming language because it need minimum 3 operands to use this conditional operator. Again, we can see question mark with colon. Question mark with colon. The combination of these two symbols we can use as a conditional operator. So this is the usage of conditional operator. See, I will take like variable equals to expression 1, question mark, expression 2, colon, expression 3. So you can take directly a variables or an expressions in a place of expression 1, 2 and 3. So the expression 1, if I am given x is less than y, and my expression 2 and 3 will be x colon y. So if x is less than y, my answer is x. So if expression 1 is true, it is going to return expression 2 is my answer. If expression 1 is false, instead of expression 2, it will give expression 3 is my result. So this conditional operator is worked similar to your if-else statement provided in control statements. Whereas the last operators in C programming language is a special operators, which is used to perform some special operations in C programming language. So we can observe these are the different operators we are going to use in C programming language for different purposes. So the first symbol is an ampersand symbol, and this is used to refer address of a particular variable or some array or whatever it will be. Ampersand is going to refer address, whereas an asterisk symbol, which is looks like a star symbol. So this can be used in two different purposes in C programming language. One is for doing multiplication, so that we can place the star symbol in between two operands. So it will do the product of two variables given. Whereas you can use this asterisk symbol before only one variable name. It is taken as a pointer variable. And a braces is simply a curly braces, which is used to provide a structural view in C programming language. And these braces used in two purposes: for defining your functions or for initializing the group of values. Whereas square brackets used in C programming language for declaring arrays. So these are said to be subscripts there. By using the square brackets, we are provided the size for an arrays. And the next special symbol is parenthesis, which is two brackets, which is used along with the functions. And then comma is a special operator which is used to separate the similar type of multiple things. Whereas semicolon is a special operator which is used to terminate a line. Period is simply we can say dot, which is used for referring of structure data members along with a structure variable. Whereas the arrow symbol is used along with pointers to refer the data members of a structures. Whereas the size of is a special operator which will give you the size of the data types. So this is about different types of operators in C programming language. And after we have a knowledge on the operators, now we are ready to do some operations in your programming. So whenever you given some expression in C programming language, so now everyone is need to give a same answer. And that can accomplish in C programming language by using the concept of operator precedence and associativity. So operator precedence and associativity concept is very important because we have different list of operators are available in C programming language, like arithmetic operators, relational, logical, increment, decrement, special operators and all these things. And among of all these operators, which operator is having the highest priority? Means when your expression is having the combination of all these operators, then which operation we are going to evaluate first? And that is given by your operator precedence. And the same operator precedence will decide whether you have to evaluate your expression from left to right or from right to left. Simply we can say the associativity will provide you in what direction you are going to evaluate your expressions. So that is the concept of operator precedence and associativity. Simply I can say, like in mathematics we have Bodmer's rule, brackets of division, multiplication, addition and subtraction. And we can find out that division, multiplication, addition, subtraction all are similar operators which comes under the arithmetic operators. Among of these four operators, we see that division is having the highest priority and multiplication is having the second highest priority and addition, the subtractions are having the third and fourth priorities. So, in a similar way, for evaluating an expressions, if you have a multiple operators and this table will describes you what will be the precedences of a different category of operators. Now you can see these are the special operators like parenthesis, square brackets, dot, arrow, plus plus and minus minus. So these are the operators which is having the highest priority than all the remaining category of operators. In next level, we have prefix increment and prefix decrement and unary plus and minus operators, not and exclamatory, that is your bitwise complement operators, typecasting, and your indirection, that is your asterisk, ampersand, size of operators. And these operators having the second level of priority. And then we have an arithmetic category, multiplication, division, modulus is having the same priority. So when we have the same priority of operators are existed, depends on their occurrence. You can solve that particular operator first. And then for addition and subtraction, both are having the same priority. And then shift left, shift right is having the next priority, that is after your arithmetic operators. And then we have the relational operators is having the next priority. And then we have bitwise and logical operators is having the next priorities. And the last priority we are given for an assignment operators. And comma. So these are the priorities or the importances of different available list of operators. So when come up with an associativity, because of this operator precedence and associativity, when you given an expression, if you are trying to solve with your computer, anywhere you can solve, it will give you a same answer. So you can solve your expression in Andhra Pradesh or you can solve your expression in Chennai, whatever it will be, the same expression will give you the same answer. So here is an example that illustrates the precedence and associativity of the expressions to evaluate. So here the expression is given as 34 plus 12 divided by 4 minus 45. So now this expression will consisting different arithmetic operators like plus, division and subtraction. So we know like plus and subtraction is having the same priority and division is having the highest priority than your addition and subtraction. So because of that, it performs division before addition and subtraction. So in this, so 12 divided by 4, we get the answer is 3. And then among of plus and minus, both are having the same priority. So plus is come first before the subtraction. Because of that, the resultant of division is going to be add with your plus. So that is 34 plus 3. We get answer as 37. So now we have only one operation is left, that is subtraction. So we can do 37 minus 45. We'll get minus 8 as your answer. So this is about operator precedence and associativity. And this topic is very important to get the same answer for your expression evaluation. And the next is, what are the different, what do you mean by an expression in C programming language? And what are the different types of expressions we have? Simply we can say expression is nothing but a formula in which it is going to link your operands with using of some operators and which are used to compute some value from this expression. In C programming language, we have different types of expressions. So that will be of an integer expression, floating point expression, constant expressions, bitwise, pointer expressions, logical expressions and relational expressions. So simply we can define all these expressions. Simply we can say integer expression is nothing but that expression will consisting both the operands of type integers. So if I take a plus b, then that is an integer expression if I provide an integer values for my variables a and b. We go with a floating point expression. Here for the same example, instead of an integers, I can provide a floating point values. Whereas relational expression, this expression will consisting the relational operators like less than, greater, less than or equal, greater, equal and all these things. Whereas the logical expression will consisting the logical operators in their expression. The pointer expressions will consisting the pointer variables. The bitwise expressions will consisting the bitwise operators between the operands, and the constant expressions which consisting the constant values. So instead of providing variables, we are provided directly a constant values like 3 plus 5 and 5 is multiplied with 6, or else 5 multiplied with 6 minus 3, like this. So we can simply provide the expression like this. Then simply we can say this is a constant expression because we are provided all the constant values here. So this is about an expression in short. And the next important topic is type conversion and typecasting. So the type conversion concept is very important for programming language because whenever we want to work with a multiple data items, like we are working with some integer and combined with the floating point values. So in any programming language, we cannot operate with multiple data items directly. Means here I cannot add an integer value with floating point. Because when I am trying to add integer value with a floating point, I'll return a value as floating point. And we think of that an integer is going to add it with float and it will return a floating point actually. But what the compiler will do is, it cannot directly add integer with floating point. It is trying to convert integer value to float first and then it is going to add both floating point values. So this type of conversion is said to be a implicit type conversion, and we can also say it as widening. So there is no need to tell the compiler to convert integer to float, because in type conversion, the compiler is going to convert an integer value to floating point. Because the integer can occupy 2 bytes, whereas the floating point can occupy 4 bytes. When I am trying to convert integer to float, I cannot lose any data. So because of that, the compiler is directly going to convert your integer to float. So we can simply say the type conversion is nothing but which is done by your compiler automatically whenever this compatibility is required. So this conversion is directly provided by the compiler itself, and this process of converting the lower data type to upper data type, we can simply say widening. So see here in this diagram, it will represent like a boolean is simply 1 bit, whereas character is simply 8 bits, that is 1 byte. Whereas short int is 1 byte, integer is 2 bytes, unsigned integer is 2 bytes, and long integer is also 2 bytes, and unsigned long integer is also 2 bytes, and long integer it makes it of 4 bytes, float is of 4 bytes, double is 8 bytes, and long double is 10 bytes. So whenever you try to convert the lower data type to upper data type, so we can't lose any data. Because of that, your compiler is directly converting one data type to another data type if it is required the compatibility between two data types. So see, this will give you an illustration like boolean is converted to character and character is directly converted to short integer, whereas short integer is converted to integer. So like this way we are going to convert one data type to another data type. Whereas the second case is explicit type conversion. So here we are doing the reverse process. Suppose see for example, if you have a glass of water and you want to pour that glass of water with a jug. So now we didn't lose a single drop of water from the glass because we know jug is a big container as compared to your glass. So that's what the compiler is done in your previous conversion, simply of your widening process. So it will convert lower to upper. Whereas your typecasting, so it is simply we can say the data type is converted to another data type by the programmer or the user while writing a program code of any programming language. So this mechanism we can known as typecasting or an explicit type conversion. See for example when we required. Suppose we go with a real-time example. If I consider one recruitment or if I come with one drive, so there I got nearly 500 applications and my main constraint is their percentage. So the percentage of each person will differentiate from one person to other person. Like if I take as a consideration like 83% of a people is differentiated from 83.5. So both are differ in my mind. So I can consider their percentage. I don't need to convert this 33 point something into directly 83. So I cannot do because my constraint is on percentage itself. So I cannot convert this floating point to, I cannot round off this floating point to integer there. So that is a main constraint. In some cases, we don't bother about that. Like we can take a consideration like who are getting more than 75% of marks. So they secured with first class with distinction. So irrespective of the percentage of that people, like they may get 93%, they may get 75.01%, whatever it will be. I considered every people under the category of the first class with distinction. So there is no restriction on that. So simply what I am trying to do is I will convert that floating point value to integer because every time I am going to round off. Why it is required means floating point I required 4 bytes of memory, whereas integer I required only 2 bytes. So when I am converting this floating point to integer, obviously I lose the fractional part. That is, I lose the decimal part of that variable. Here I didn't consider with that percentage, I just want to round off because here my consideration is memory. So simply what I am doing, I am forcefully converting floating point to integer and whatever the value it will be after rounded. Because we all know when you are doing rounding operation, we'll get the value as 5 or greater after the decimal place. It will add 1 point to the previous value or else it will subtract. So some people may get advantage and some people may get somewhat drawbacks. So that is of my constraints. Depends on my constraint. The programmer, they need to convert one data type to another data type forcefully. That is simply we can say the larger data type to smaller data type. See here. You can observe here, this is your higher data type. See, for example, if I am trying to convert floating point to integer, because float is 4 bytes, whereas the integer is 2 bytes. So I am trying to convert, I am trying to shrink this value. So then what's happening? This 4 bytes of information is converted to 2 bytes. Obviously, I lost some data. Because of this reason, the compiler doesn't directly convert your floating point value to integer. It will take a permission. So user can do this explicitly. So for doing typecasting, we can use this as a syntax for expression, what type you are going to convert. So you can give like this. So in brackets you can provide a type. See here, my variable is floating point and my variable name is average. Now I want to convert this average into integer. I can provide int in between brackets. So this is a typecasting. So typecasting and type conversion both are used to convert one data type to another data type, whereas the type conversion is done by your compiler itself and the typecasting is converted by the or explicitly or forcefully converted by the user or the programmer. So this is about the today's topic. So after we discussed about the formatted and unformatted input-output statement, now we get the complete idea and we get the complete knowledge to write the programs. So after completion of that session, I'll give you more examples how we are going to use all these type of operators, and then we can use some important programs how we are going to implement. Thank you so much for watching. Thank you. Please like, share and subscribe my channel Tech Tutorials, and you can find out more videos and more lectures in this channel. Thank you.